Last time we talked about the Cobra chassis and I got it finished, pretty pleased with it. You kind of put it back and let it incubate a little bit to kind of see what changes, what modifications you want to make on it, or is it as you want it, or so forth. And I was pretty pleased with it. But now, then, after that, I'm watching a television show on PBS or Discovery or something about Pan Am Airways and how they were a little bitty airline company. They got a FAA awarded them a route to Panama. They got all the Central and South American routes, and they got very big very quickly. Well, and they used what they call clipper ships. They were amphibious airplanes to service these routes. Well, Igor Sikorsky, famous name in aviation, was their plane designer. His company built their airplanes. And another famous name, Charles Lindbergh, was their vice president in charge of the airplanes. Well, they grew fast. They needed a bigger, faster, nicer plane, more passengers, so forth. And Sikorsky presented the prototype drawings, and Lindbergh said, no, this thing, you got too many spars out here, it won't be fast enough, and so forth. And Sikorsky says to him, yes, but this is the engineering of the possible. This is what we can do right now. This is what we have the technology for, and this is what we can build. Well, I've never heard the term the engineering of the possible before, but that fascinated me because I realized that's what you do, that's what you always do, that's what I've always done. I've just never heard the term before. But it's the engineering of the possible. And the engineering of the possible, I mean, you know, little bitty shops have got CNC machines in them. Home Depot's got three printers for sale, 3D printers for sale. You know, $100 will get you a dang good AutoCAD program. Carol Shell, there's more stuff in here than Lamborghini had in their tractor factory, and you know, Carol Shelby had to lay it all out on butcher paper on the floor and draw out a chassis that way. Been there, done that. That AutoCAD program's a whole lot easier. But I was fascinated by that, the engineering of the possible. Okay? Now, after that, I get an email from Cormark. Cormark is my steel and aluminum distributor here. Cormark says, we have purchased a tube laser. We're looking to keep this thing busy. $140 setup charge, $140 an hour. And I'm thinking, a tube laser is like a CNC machine for tubes. It rotates the tube, it cuts stuff, it does all kinds of things like that. But I'm thinking, you know, a whole Cobra chassis, the tubing, I bet there's not 50 feet of cut. If 10, 12 inches a minute, that's an hour, $280. Let's look into this. Turns out it is conventional feed rates and so forth, and you're looking at about an hour to cut it and a $140 setup charge. So after a little investigation, the good news is they have the tube laser. Bad news is they have two locations. One is here in Fort Worth, Texas. The other one is in Minneapolis, Minnesota. So after a few conversations with them, I am off to Minneapolis, Minnesota. And this is what I brought back with me. Tube lasered chassis. This is pretty cool. Didn't know what the tolerances, how to do this, but this has worked out well. Here's a tacked together frame rail out of tube lasered rectangular tubing. This is where the shock pieces, this is just a scrap piece, pretty nice scrap piece there, isn't it? This is just a scrap piece, goes in here just to show the fit. Everything on it, the rivet holes I've already had pre-cut with a tube laser. The rivets, the tolerances are just fine on it. My Hayco plugs, just exactly the tolerance I want. Everything's great on it. Come around here and I'll show you a few things here. These places here, you don't have to dog bone anything. See the notch right here? You don't have to dog bone it, but it's the same notch and fit type construction. One thing I did have to dog bone, this is where the 4-bar links go. They're gonna go in these little dog bones here so I can get some weld on the side once those are in. But you can also see how by doing it this way, and again these are just tack, but you've eliminated what I call the bastard cut, which is an angle here that just makes no sense at all and is hard to do on a miter saw and so forth. You've done this, now you've got plenty of strength, plenty of weld. Just really digging this. Again, just a few thousandths clearance on it. Oh, let me show you. This is a cross member that goes back there. I thought that was pretty neat. So that's where we're at on the Cobra right now. Got my metal pieces back. These are the shock mount and four link mount for the rear ends. Josh at Production Metal down in Houston's water jetted these for me, and called him today and said everything looks good, tolerances are good, proceed. So we are going forward with the Cobra project. That whole engineering of the possible thing goes back to something else I have said for many years. Two kinds of satisfaction. You do the best you can with what you got to work with, or you have all the tools to build something. How good can you do it? I think about those kids in Thailand building Lambo replicas out of trash cans and coat hangers.
Pakistan.
No, they're in Thailand.
Oh.
And I got as much respect for them as I do any big time car builder here. But that's where we're at. This tube laser stuff, that's a whole new technology that I am interested in exploring further. Now, don't think people are asking, what about the Chupacabra project? This has not replaced the Chupacabra project. It is still ongoing. We have a meeting this Thursday with the Washington bureaucrats again to discuss a bunch of more of that. We're still waiting on NHTSA. We're still waiting on the lawsuit that was filed on our behalf with SEMA. The problem with the Chupacabra project is not building Chupacabras. The problem with the Chupacabra project is building a car company under new laws when nobody has a clue. So it's still there, it's just a long, tedious deal. One final thing. Did I mention that Bonnie and Clyde stopped by for the weekend? The reason I bring that up is I want to show you, come around here, see if you recognize the rack and pinion and the A-arms and so forth under a 34 Ford. It is just exactly the same rack and pinion, same A-arm configurations as what I use on the Chupacabra, as well as what I used here, which is what's commonly called a Pinto Mustang II front end. Back in the mid-70s when that came out, nobody had ever seen a compact little rack and pinion, and that the whole front end, Pinto Mustang front end, became the standard setup for every hot rod, street rod in the world. So here you have three radically different cars that are all using the same front end configuration, the same 24.5-inch magic number, all the same geometry. I think that is everything I wanted to show you this time. I'll glance at this real quick and see if I left anything out. Well, I probably did, but I think that's about it. I will shoot another video once we get this farther along.